this weekend for emails. Okay, so in that case, let's start 1.8, absolute values and absolute inequalities. Okay, so an absolute value is of the form like this. So just a line, X in the middle, right, when it comes to it. And this concept is an explanation for distance. Okay, so the biggest way I can understand what a concept of absolute value is let's suppose you're sitting here. Yeah, you're at your desk, I don't know, if your car, whatever. And let's suppose that you have to walk to your, let's say, front of your door. That's your door. Okay. And let's suppose that distance is 10 feet, just for, for fun. So this is you. This is the door. Okay. So if you start here, the distance from you to the door is 10. And fun fact, what is the distance from the door back to you going to be then? Anybody can answer.
10 feet.
10 feet.
10 feet.
Yeah. So it's the same, right? So what that means is, well, it's not negative, right? You're not going backwards in time, right? We know there's no such thing as going backwards in time. So it's still 10, it's still positive, right? And that's what this concept of absolute value was into play. So when it comes to the absolute value is mathematicians made up this portion to describe what's actually happening here. And they call it the absolute value, okay? So it doesn't matter if you start here or there, it's going to be the same distance no matter what, okay? And that's when this distance comes into play, okay? So no matter if you go here or there, you're going to get a positive or a negative, right, when it comes to it. So for example, for the absolute value of x equaling 7, well, x can equal literally 7, or it could be -7, because that distance is going to be the exact same way. Because if I just go from 0 to 7, well, I can start here going that way. That gives you 7. Or I can just go the opposite. Well, how do I go from 7 back to 0? I have to subtract 7. So that is where we get the two answers when it comes to the absolute value. So you're always going to get a positive and also a negative of it when it comes to it. Again, and all it is describing the distance when it comes to here. Any questions about that at all? No? Pretty straightforward when it comes to it? So one thing I do like about your book, or the book of this is, it's pretty straightforward. It doesn't go around the bushes. It just gives an example, and it pretty much tells you, okay, for every case, this is what's going to happen. And I kind of like that because a lot of other books just go around the bushes and give you like tons of scenarios and trying to guess on what's actually happening. This book actually gives you pretty straightforward kind of thing here. Okay, so being this concept, not only are we going to be doing equal to, but we're also be doing inequalities. Right, so the less than or greater than, or equal sign and a not equal sign when it comes to it in general. So when it comes to these next examples, all we're going to figure out is which case we're in, and then from there, that's exactly the pattern we're going to be following when it comes to it. And then again, we're going to go write it all in interval notation. Now for case 1, there is no interval notation, just omitted, so you just put none. But for case 2 and 3, we actually have the intervals right here for us. Okay. So when it comes to case 1, we have the absolute value equals a number, so literally the same process we have above. So we're going to have the positive and also the negative, because again, we can have positive or negative going forwards or backwards. Okay. If we have the absolute value is less than a number, or the absolute value is less or equal to that number, again, we're going to have this case here. We're going to have the negative on the left, the positive on the right, and X on the middle. Again, depending on if it's, equality or not. And from there, that's going to be our interval notation. Because remember, we talked about this yesterday when it comes to brackets and parentheses, right? Brackets because it's the equal sign, parentheses because there's no equal sign there. Okay. Now, the only case is a little funky is case 3. So we have the absolute value is greater than a certain number, or again, the absolute value is greater than or equal to a certain number. This one is a little different. We're going to have X is greater than the positive, and X is less than the negative of it. And then from there, same thing applies for the equality symbol. Okay, and then from here, we're going to have 2 interval notations, kind of like we had on the last section, right? When we did the rationals, right? We had to split up the number line. We had two, false, true, and false, true. Same exact process comes into play here. Okay, so I know it's a lot of theory, right? So why don't we do some examples to illustrate this, make it a little easier for ourselves when it comes to it. Okay, so let's do just a case one example so you can see how would that come into play. So this is just a case one example. Okay. So the absolute value of 2x minus 3 equals 8. All right, so this is a case one. So going by our rule, it's going to be whatever is on the inside equals the positive, and whatever is on the equal equals the negative of it. So we're literally going to copy exactly this down. And the same thing, but now it's just going to be the negative of it. And that's it. And now we just solve for x accordingly for each case. So plus 3, that gives us 11. Divide by 2. So that's one answer. And now we do the same thing for the other one. So plus 3. This gives me negative 5. Divide by 2. And we get our other answer of negative 5 over 2. So these are our two answers for this scenario. Again, just following just what case one tells me to do. Any questions here at all? Everybody comfortable? Not too bad? Definitely want more like this on the test? Easy peasy? Hopefully. Okay. All right, so now let's go a little bit more difficult, case two. Okay. So let's suppose we have this for case two. Just a little harder. Okay. All right, so before we do anything, so I know it says, all right, we're already in case two. However, the first thing you have to do is make it look like that. So we have to have only the absolute value on one side and just a single number on the other side, which means the first thing we have to do is get rid of this 3 over here. So to get rid of it, right, we just add it over. So now we have exactly what our rule says we're going to do. Right, so now it's exactly how we have it there. Absolute value on one side, the inequality, and a single number on the other side. Right, so just in case you have a number here, first bring it over, then we're going to do our case rules itself. Okay. All right, now notice we're going to do exactly what we also learned yesterday. So it's going to be a minus 6, because that's the k value, less than or equal to 3x plus 4, less than or equal to 6. And again, just like we learned last time, we solve for x just like we do, but all three sides, right? So again, quick review what we did yesterday. If I cover that up, we just subtract 4. And if I just cover this up, we would also subtract 4, right? So just do it to all three sides. And then lastly, divide by 3, again to all three sides, left, middle, and the right-hand side. Okay, and there we go. There's our answers. Now let's suppose they wanted an interval notation. Well, again, if you're a little confused, well, we're just going to follow the case value. So we got here, right? That's the end result we have here. And now when we want to interval notation, it's going to be, since we have equal signs, right? It's going to be less than or equal to, less than or equal to. So we're just going to have brackets. So our interval notation is going to be bracket, negative 10/3, comma, 2/3 with another bracket. Again, just following the template we have there. Any questions on case two at all? Easy peasy so far? Much easier than the applications we did yesterday? Pretty sure you guys are happy we're done with applications so far, right, when it comes to it. Okay, so now let's do the last case. Again, I think it's the most difficult because it's more to think about. So case 3. Okay. So let's say we have something like this. So 5 times the absolute value of x plus 1 is greater than 15. So again, before you go jumping everywhere, again, you have to follow exactly this. So it is case 3, it's greater than, but we don't have exactly what we want. Again, we want absolute value, the inequality, and a single number. Unfortunately, we have a number here, right? So remember, we want to isolate this. So if it's 5 times this, so therefore the way to get rid of it is to divide by 5. Again, right, it's the opposite. So since we're multiplying, opposite would be to divide. So these cancel, and now I get exactly what I want, just the absolute value on one side. And then 15 divided by 5 is going to be 3. Now we have exactly what we're looking for. So again, before I go any further, everybody comfortable about this step here? I know sometimes this gets a little funky, right? Because we're not adding 5, we're not subtracting 5, we're multiplying the side, so therefore we have to divide to cancel out, just like, you know, if we're solving for a variable. Just like we did here, right? We would divide by 3 to cancel that 3 out. So all good on this step here? Yeah, you guys are quiet today. Okay. Lonely Thursday? You guys going out drinking today? Thirsty Thursdays or something? Or you guys have a hangover? Yeah, who knows? That's the sucky part about not seeing your guys is I can't make fun of you guys if you guys all come tired or something. Anyway, sorry. Got off topic there. All right, so now that we have that, so now again, we're just going to follow the template. So we're in this case, right? Not this one because it's just a regular one. All right, so it's going to be x plus 1 is greater than 3. So notice I just copied that down. Notice it's very similar to this one, right? Okay, or x plus 1 is less than negative 3. Right, and notice all I'm doing is following exactly what it tells me to do, right? So remember, this x right here represents everything that's inside the parenthesis. You guys have hopefully noticed, right? It represents everything inside the actual, well, not parenthesis, but inside the absolute values portion. And now we just solve like we did the last 2 scenarios. So minus 1, minus 1. So we know x is greater than 3. Or in this case, minus 1, minus 1. X is less than negative 4. Okay. And now finally, we just write it in interval notation. So again, like we did yesterday, how do we write this? So x is greater than 3.
That would be 2, right?
Which one? Oh, yeah, thank you. This is a 2. Thank you for catching that. Sometimes I go a little too fast for myself. Thank you. Yeah, so that's a 2. 3 minus 1 is 2. Thank you for that. So x is greater than 2. So again, going back, how do we write that? So anything bigger than the 2 works. So therefore, the smallest is going to be 2. And the infinity symbol is going to be there, right? Because it goes on for forever. And then we do the same thing on this side. In this case, says x is less than negative 4. So everything less than negative 4 works. So that goes to negative infinity because it means everything smaller than that. And the top number is going to be to negative 4. Right. Now, when it comes to homework and the quiz, I'll be pretty lenient. Like, usually you want this one first because, that's the smaller of the 2. So it should look like this in the proper order. But, I'm happy with either one. Because you understand it if you give me that. So that's just kind of being picky when it comes to it. But hey, I know not everybody's a math major, so I'm not going to be so anal about that kind of stuff.
So the reason why that was considered case 3 is it because we were multiplying against the absolute value?
No, it was case 3 because It was the absolute value is greater than a number.
Ah, okay, I see that.
That's
Thank
why. So case 2 is less than, and case 3 is greater than. That's why. So whenever you have the absolute value is greater than a number, you're automatically in case 3. And if you have the absolute value is less than a number, you're in case 2. And if it's equal to, you're just in case 1, where you just split it up, and it's just gonna be plus or minus, and just, it's a little bit less work because it's, equal to, but when it comes to these ones, you just gotta be very careful in what case you're in. And again, just follow the template when it comes to it. Yeah. So any questions on the 3 cases so far? Everybody comfortable? Okay. Let's do one extra one. Yeah. So let me just keep the cases here so you guys can see it. Or, yeah. Let's try this one out. Okay. So hopefully you got it down. So this one's a little different, but it's a combination of this one and this one here. Okay. Oh, the first cases. So case 2 and case 3. We had the times and we also had the subtraction of the 3. So all we do is just do both these ones before we even do our rule. Okay. So the first thing is we want to isolate this. So basically you can think of, okay, how do I get this by itself, right? And it goes back to the first day of class, right? Just solving for a variable. And that's what that means by that. So when it comes to solving for a variable, adding, subtracting comes first. So since we're adding 2, so therefore we get rid of it, we have to subtract 2. And now notice, now we're in case 3 kind of scenario, right? Since we're multiplying by 5, we had to divide. So therefore, since we're multiplying by 3, get rid of it, we have just divide by 3. So those cancel. And we finally get the absolute value by itself on one side of the inequality. And now you notice we're in case 3. Right? So we have absolute value is greater or equal to number. So we're in case 3. So here's your first extra credit portion. Go ahead and finish the problem and write your answers in interval notations. And just go ahead and put it in the chat. Go for it. Give you guys about 3 minutes. It's fine. Anybody else want to try for extra credit? Okay. 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 Did everybody try? Okay. So let's see. Let's see who got it right. All right. So since we're in case 3, right? So therefore, we're going to follow this template. So it's going to be exactly what we have inside the absolute value is greater or equal to that number. We're also going to have, again, exactly what's inside the absolute value, and just flip the sign. Yeah, flip the sign, and to the negative, so -2. No, 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 no. What am I doing? Greater or equal. Yeah, there we go. Okay, so now we just solve individually. So +3, +3. This is 5. And this is a little tricky. See if you guys remember. We divide by a negative. Anybody remember our rule when it comes to dividing by a negative? We flip the sign. So fun little trick there. So you have to do it for both of them here. So +3, +3. This is +1. Again, divide by -4. Since we're dividing, we also flip the sign. And there we go.
I thought when we bring both values down, we are supposed to initially flip the sign. How you initially did, but you crossed it out. The -4x - 3 would be less than or equal to negative.
Yeah, that's why I'm confusing myself. I don't know. Did I just mess up? I probably think I just.
I think you had it correct the first time.
Oh yeah, I did. This is what's messed up. These are the messed up ones. No, this one's right. This is incorrect. This one's flipped. That's the one. I was wondering why. I was second guessing myself here. Yeah. So this was correct. So in the end, ends up being this side. Yeah, there we go. So it was this way. That way. So this one's good. This one's wrong. This is the wrong one. Okay, there we go. That's what I get for copying and pasting down there. Okay, but before we go any further, everybody remember about that little rule there, right? So that could be a big issue sometimes, especially for your homework. I believe you have 2 questions like this, where you have to flip the sign itself. So remember, whenever you divide by negative, you have to flip the sign. You just flip it. So in this case, it was 2 flips in this scenario, okay? So therefore, when you do interval notation, x is less than this value. So we know -infinity to -5/4. And since we have a bracket, so there, right? So remember, there's no bracket on parenthesis, right? No bracket on parenthesis, just on the k value. We have equality. And same thing over here. X is greater than -1/4. So bracket on the -1/4, and to infinity. Again, right, notice just following the template we have there. And if you want, you can put the U. I really don't care. But yeah, you can put a parenthesis. I'm good. Again, as long as you have both of them, I'm happy. You don't have to put them in this order if you don't want to. So, any questions on this example here at all? Is everybody good? So if you didn't get these, everybody see where your little mistake was? So it looks a lot of you guys just forgot a negative. So that's not a really big deal. So that's really easy to change. So no questions? Okay. Assuming silence is A-okay, easy peasy. Just a minor mistake here and there. Okay. Good. So believe it or not, that finishes 1.8. Kind of nice, right? So much faster than what we did yesterday, right? So when it came to it, so I know, like I said, 1.5, I took my time because word problems could be really, really hard. So I tried to do my best to slow the pace down and make sure we just get through all of that portion when it comes to it. Okay, so